In this task, you'll learn how to perform a join. Your organization has diabetes morbidity counts by neighborhood in Baltimore. They're stored in a database table and are not currently associated with the GIS layer. Therefore, in their current state, you can't display the data on a map. So you'll join that data to the neighborhoods layer so that this data can be rendered on the map. Here I have QGIS Desktop open with the QGIS map document I saved at the end of task 1. I'll start by adding a table. I'll click the Add Vector Layer button and browse to my lab data folder. In the Open an OGR supported vector layer window, I'll set the file type filter to all files. And I'll choose the Baltimore City Diabetes Neighborhood DBF file. Click Open and Open to add it to my QGIS Desktop document. The table is added to my Layers panel with a table icon. There are two requirements for a table join. First, the two tables need to have a common field upon which the join will be based. Second, there needs to be a cardinality of 1-to-1 or many-to-1 between the attribute table and the standalone table. Now I'll open the table by right-clicking on it and choosing Open Attribute Table. The table has two columns, one with the neighborhood name and one with the population diagnosed with diabetes. Now that I'm familiar with the table, I'll close it. Next, I'll open the attribute table for the neighborhoods layer. I'll right-click on it and choose Open Attribute Table. There's a column with the neighborhood name, and then many columns of socioeconomic data from the 2010 census. And now that I'm familiar with this data, I'll close this table. In this case, there's a column containing the neighborhood name in both tables. There are 271 records in each table, meaning there's a cardinality of 1-to-1. So we've met the requirements for a join. To start the join, I'll open the layer properties for the neighborhoods layer. And I'll switch to the Joins tab. I'll click the green plus button to add a join. The Add Vector Join window opens. The join layer is the table I wish to join to the neighborhoods layer. So I'll click the Join Layer dropdown and select the Baltimore City Diabetes Neighborhood table. As I discovered while investigating both tables, the field that the join will be based on is called Name in each. So I'll select the Name field as the Join field and the Target field. I'll take the remaining defaults and click OK to create the join. The join now appears here on the Joins tab for this layer. I'll click OK to close the Layer Properties window. To see the results, I'll open the attribute table for the neighborhoods layer. I'll scroll to the right to see the new column appended to my attribute table. The new column name is the join layer table name followed by the column name. I'll close the table. Joins only exist in virtual memory within the QGIS desktop document, so the data are not permanently attached to the neighborhoods layer attribute table. To preserve this join outside the map document, I'll right-click on the neighborhoods layer and choose Save As. I'll make sure the format is Esri shapefile, and I'll click the Browse button next to Save As and navigate to my lab data folder. I'll name this file Neighborhood Diabetes. I'll click Save and OK. The blue bar indicates that the process has been completed, and I see the new layer in my Layers panel. To investigate the result, I'll use the Identify Features tool. I'll select the Neighborhood Diabetes layer in the Layers panel, and I'll click on the Identify Features tool. Once I've selected the tool, I'll click on one of the neighborhoods on the map. The Identify Results window can be expanded so you can see all the data or resized. On the left are the attribute columns, and on the right the corresponding values. So this particular neighborhood has a diabetes count of 849. This tool gives you an interactive way to explore the attribute values of a layer. And as handy as the Identify Features tool is, it'll be much more powerful to be able to see all these data on the map graphically. So I'll work on styling the data. I'll close the Identify Features window, and I'll open the layer properties for the Neighborhood Diabetes layer. I'll switch to the Style tab. So far we've only explored the single symbol renderer. This time I'll click the drop-down to the right of single symbol and choose Graduated. This allows me to classify the features on the map by a numeric attribute column value. I'll choose Baltimore City underscore D as the column, which has our diabetes values. Then I'll click the drop down next to color ramp, and I'll change this to reds. I'll set the mode to quantile. This method of classification tries to put an equal number of features, neighborhood polygons in this case, in each class. And I'll leave the number of classes at 5. So now I have a column for the attribute column values and a column for the legend. The legend column contains what will be seen on the map legend. There are some extraneous decimal values, and to clean this up, I'll double click on each legend value to edit it. The top class can just be changed to 0. So I'll double click on that, enter a 0, and hit return. The next class can be edited to read less than 105. The bottom class can be edited to read greater than 498. I'll also remove the decimal places for the middle classes. I'll click OK to accept these changes, and now I can visually see the data that had been stored in the attribute file. Now I'll do some cleanup. Since the data are now attached to the new version of the neighborhoods layer, I no longer need the original join. To remove the join, I'll open the Layer Properties Joins tab for the neighborhoods layer, select the join, and click the Remove Minus button, and click OK to close Layer Properties. The join was an intermediate step. Finally, I'll right-click on the table and choose Remove. In the final task, I'll geocode some address-based data.